A German physicist, Robert Kirchhoff, introduced two important electrical laws in 1847 by which we can easily find the equivalent resistance of a complex network and flowing currents in different conductors. Both alternative current circuit and direct current circuits can be solved and simplified by using these simple laws, which is known as Kirchhoff's first law, also known as Kirchhoff's current law or KCL, and Kirchhoff's second law, also known as Kirchhoff's voltage law or KVL. Also note that KCL is derived from the charge continuity equation in electromagnetism, while KVL is derived from Maxwell-Faraday equation for static magnetic field. The derivative of B with respect to time is 0. In this video we discuss about Kirchhoff's first law KCL. To understand Kirchhoff's first law, KCL in simple terms, let an example. Water is passed through two different tubes of water, W1 and W2, which meet at one junction and further exits three different water tubes, W3, W4 and W5. Thus, sum the amount of water coming to this junction is equal to the sum of the amount of water going through the junction. So, W1 plus W2 equal to W3 plus W4 plus W5. Now W1 plus W2 minus W3 minus W4 minus W5 equal to 0. Similarly, in electrical network circuit, currents I1 and I2 came two different branch, which meet a junction, further currents I3, I4, and I5, going away from the junction. Then according to Kirchhoff's first law, the sum of the currents at a junction is equal to the sum of the currents going away from the junction. So, I1 plus I2 equal to I3 plus I4 plus I5. Now, I1 plus I2 minus I3 minus I4 minus I5 equal to 0, or, we say that summation of incoming currents equal to summation of leaving currents. In other words, according to Kirchhoff's current law, at any moment, the algebraic sum of flowing currents through a point, or junction, in a network is 0. Or, in any electrical network, the algebraic sum of the currents meeting at a point, or junction, is 0. This law is also known as point law or current law. Or, in any electrical network, the algebraic sum of incoming currents to a point and outgoing currents from that point is 0. Or, the entering currents to a point are equal to the leaving currents of that point. In other words, the sum of the currents flowing towards a point is equal to the sum of those flowing away from it. Or, the algebraic sum of the currents entering a node equals the algebraic sum of the currents leaving it. Get an example for understand. 8 ampere and 5 ampere currents is coming towards junction point and 6 ampere, 3 ampere, and 4 ampere are leaving that junction point in figure. Therefore, I1 equals 8 ampere, I2 equals 5 ampere, I3 equals 6 ampere, I4 equals 3 ampere, I5 equals 4 ampere. According to KCL, incoming currents equal to leaving currents. That means I1 plus I2 equals I3 plus I4 plus I5. So keep value in above equation. 8 ampere plus 5 ampere equals 6 ampere plus 3 ampere plus 4 ampere. Now 13 ampere equals 13 ampere. Hence, like this, currents entering at the junction equal to currents leaving the junction point. Thanks for watching this video. Like, share and subscribe our channel for more videos.